All right. Welcome, everybody, to the final project presentations and demos for the CSE 125 course. I'm the instructor, Geoff Voelker, and I'm here today with the TA for the course, Alex Goldberg, and all the students in the course. And what I'm going to do before we launch into all of the students demoing the projects that they've been working day and night for over 10 weeks, I'm just going to give you a little presentation to give you a sense of what the course is about, how the course works. It's a little bit different than sort of your standard typical computer science course, and give you a little insight as to what happened over the quarter. And then we'll launch into the demos. So this course is relatively unique in the sense that there's just one project that the students have to work on. And I asked the students that they have to be very, very self-motivated in working on the project. Really, everything that they're doing is because of them. It's not because of me, because I'm urging them on. And it's targeted towards graduating seniors. So these are students who have taken almost all of the computer science undergraduate courses, and they're all ready, raring to go, and they can take everything they've done, put it all together into the project. Another big aspect of the course is that they work in groups, relatively large groups, 5 to 6 people. It's a project that they work on that's too large to be done by any one person. And so actually a big aspect of the course is they have to learn how to work together, to collaborate, to cooperate, to communicate. And that can actually be a challenging thing. In other courses, maybe you have group projects, but one person may be able to pull it off. But in this course, everybody has to band together to make it work. They use a large number of tools to actually make their projects. They don't build everything completely from scratch, and which tends to be a little bit different from, let's say, the 2 to 4 week projects we might do in other courses. And then we have a very high bar. The projects they do, the games that they build, are very demanding software systems, and it's a very, very challenging project to do, particularly in the span of just 10 weeks. But what I try to tell them, and I think they believe this in the beginning and they believe it in the end. In the middle, I'm not so sure, but to have fun while they're working on their projects. And from my perspective, in putting the course together, it's actually very, very simple. As easy a course to put together as you can imagine. There's just one assignment: implement a distributed real-time multiplayer 3D game. You have 10 weeks. We hand it out on day 1, and it's due today. So you are seeing their final submissions of their projects for the quarter, and I wish them good luck at the beginning. And they've performed amazingly over the quarter, which you're about to see, and hopefully you'll agree. And the project is a game, but it's easy to forget that the games are very challenging applications. So from my perspective, the research that I do here on campus is in networking and computer systems, and I want the students to experience the design and implementation of a very large, complex software system that's non-trivial and that takes a fair amount of time and a fair amount of effort to put together. And a game fits that bill beautifully. It's distributed. We have multiple players playing over the network. It's real time. It has performance demands. We need these interactive frame rates so that the games are very, very smooth, interactive, something that you want to play. And it's also very, very complex because you have all these different aspects of the game. You have the graphics, you have the server networking, you have AI, you have sound, all of this stuff thrown in together, and it all has to work together. And it just so happens that games, although a very, very challenging application, also happen to be fun, which I think helps a lot. And this is a course that I wish I could have taken in college. I would have signed up for it in a second. But nobody did anything like this, way back in those dark ages. So I'm doing the next best thing, which is to teach the course. And let me just give you a brief overview of how these 10 weeks work. So in the first week, it's a little bit unusual. In the first week, we do a couple of lectures where we go over the history of the course, introduction, how the course works, all that fun stuff. And these are just lectures in classroom like normal. At the same time, we're doing some design and specification of the projects. This is when the groups get together and figure out, all right, what kind of game do we want to do? What kind of features is it going to have? What is it going to look like? What's the story behind it? All that fun stuff. And they have to put together a set of documentation, put it up there for us to review and to give them feedback. And then for the rest of the course, it's all about implementation. So they've set out what it is they want to do, and then in the next 8 weeks, it's all about making it work and delivering. Now, while we're doing this implementation phase, we're no longer doing sort of formal lectures in the classroom. Instead, we're running each of the groups sort of as a development group, where the TA and I are sort of the group managers. So we have weekly meetings where Alex and I would meet with the groups to find out what's going on, talk about problems, try to resolve problems, talk about what it is to prioritize for the next week. And as part of this, all the students put together status reports talking about what they did, what they didn't do, what problems they ran into, what design decisions they decided to make. And then they do updates of their schedule. And all of this stuff is documented on their web pages for their group. So if you have any curiosity as to what happened over time, you can go to these web pages, you can see where the students were thinking at the beginning of the quarter, and then go through each week and then find out what they were thinking at the end. And it's actually a little bit of fun to read these reports, because one of the things I do is I ask them, tell me what your morale is for this week. Are you feeling good, feeling bad, worried, panic, whatnot? And with these reports, you tend to get a little bit more insight as to what's going on with the students that you might not normally know just by meeting with them or talking with them. So let me just give you a few examples. So for example, you start to get the sense that maybe they're working a lot and they're spending a lot of time in the lab, and maybe they're not getting as much sleep as maybe they want to. And then you might find out that late night in the lab, down in the basement, that they might be doing things out in the corridor that maybe they perhaps shouldn't be doing with this chair ball stuff. But at least it's some kind of sports activity, so at least they're getting some kind of exercise. And then something that I always tell the students is that the course is very demanding, it requires a huge amount of time, and of course it's not the only course that the students are taking. So I really ask them not to let the course interfere too much with some of the other classes they're taking this quarter. But every once in a while you get some indication that maybe there's some interference with this course and some of the other courses that they might be taking. So the student knows who he is who wrote that. So I hope everything worked out in the end. Okay, so one thing that I wanted to do was that, so I've been teaching this course. This is the 8th time I've taught the course. And, in the computer business, technology evolves very, very quickly. So we've seen a lot of evolution of technology throughout the course. And what I want to do is sort of survey this technology evolution, but as seen through the sleeping habits in the lab. So, early on, we had sort of low-tech sleeping bags, and that's what the students would use to sort of catch a little bit of shut-eye in the lab. Not that anybody was sleeping in the lab. And then, a couple years later, somebody decided to drag in a couch. That certainly sort of makes things a little bit more comfortable. But this year, the students took it to a new level. And they brought in the aero bed, which is very impressive. And it does look very comfortable. But one day, you find out that, the aero bed, that's got to be the greatest thing, right? But something's wrong here. Either that countertop squeezed in between the printer and the cabinet, that's really incredibly comfortable, or actually the aero bed maybe just sucks. I don't know. I couldn't figure it out. But you see some strange things throughout the quarter. Okay, so one thing that I really want to emphasize when you see these demos is that in every way the students made this class successful, in every way they made their project successful. The project ideas are entirely their own. They came up with them. These are, this is what they wanted to do. And they solved all of the hard problems themselves. It's a very complex development environment. They're learning and experimenting with new tools that sometimes are buggy, and they have to figure out how to work around all of this stuff. And it's just a very, very challenging environment. And a lot of the times they hit problems, certainly I don't know what the answer is. Sometimes, Alex is there to sort of back them up. But it's just a difficult project to go through, particularly when you're under such time pressure with 8 weeks. And so what I want you to keep in mind when you see these demos is that the projects reflect the outstanding independence and personal initiative and the problem-solving skills of the students in the class. This is really what they've done, and hopefully is a reflection of what they've learned as they were students here in computer science at UCSD. And from my perspective, where at the beginning of the quarter there's just nothing, until the end of the quarter now, and it's just an incredibly impressive process to watch, to see what the students are able to do. It's just amazing, amazing. So what I'm going to do now is just give you a very quick run through the quarter, and then we'll transition into the demos. Okay, so it's the first week, it's the beginning of the quarter. Everybody's very enthusiastic. Games, yes, I really want to do the game. It's going to be fun. And, how hard could it be? Yeah, it's just a game. We got 10 weeks, lots of time. And then around 5th week, we hit this stage called integration. And that's where everybody's been working on their own module, and now everything has to be brought together, hooked together so that it runs, and everything interoperates. And that's when you discover that it's actually an incredibly challenging process to take code that you've been working on and somebody else has been working on, the assumptions that each of you have made, and try to get it to work together. And that's when you can start to have some difficulty. So in some sense, integration winds up being perhaps the most challenging part of the quarter, because that is when everything comes together. And I try to tell the students that yes, it's really tough, takes a lot of time, it's really hard. I know you're spending all week, all weekend, day and night there, but you're not the only ones working hard. Faculty, faculty, we work hard too. And maybe we take some time off when you're integrating over the weekend, and maybe we take a break, but we're trying to work hard too. And then around the 8th week, something really magical happens, which is that these designs that the students came up with in the very beginning, they're just sketches, ideas in their head, everything that you just see on paper. And then 8 weeks later, it transitions from sketches on paper into these amazing games. In just 8 weeks. It's just truly incredible. And then finally, 10th week comes. It's the crunch time. Everything has to come together. Everything is leading up to today for them to demo their games. And lots of fun stuff happens in the lab. They tend to almost practically live there, which is fine. But something, there is something really, really interesting that happens, because in the last week, there's this transition where the students are spending as much time playing their game as they are programming their game. And when that happens, they have a game that they really enjoy, that they really like, and that they've made it. Okay, before we do the final transition, I just want to acknowledge a number of people who have really helped out with this course. There's a lot that goes into it, and a lot of people help out. There's Joe Lunsford, Sally Wittucky, and Steve Hopper, who do a lot of the system administration. Todd, Helena, Hector, and Doug, who really put together everything that you're seeing here, supporting us and being able to do these demos. And then this quarter in particular, we had a fantastic set of guest speakers from folks from local game companies: Henry Yu, Stephen Waits, Kyle Forbes, Steve Rokenberg, and Wolfgang Engel. And it's really, really fantastic for people who are in the industry, have been there for a while, can come and give the students a lot of advice and insight as to what's going on in the real world of actually making games as a business for fun and profit. And then Mark Rotenberg also this quarter gave us some great content for use in the games, although we wound up not using it too much, but it was just incredibly generous for him to take the time out to capture this content and make it available to the groups. And then finally, Mark Hayes and Sam Stokes from Microsoft are the university relations folks at Microsoft, and they're the ones who sort of give us all the free software so that the students can program and develop at home, on their laptops, while they're traveling, everywhere. And then finally, I would in particular like to give a very special thanks to Alex Goldberg, the TA for the course. He's the one who answered all the hard questions when the students were having problems. So I can guarantee you that I was never sitting down in front of a computer with the students behind me wrapped with attention, being amazed at what's going on. It was really Alex who came through with that. And then here's what we're going to do for the rest of the time. We have 4 groups. We're going to demo 4 games. And Neat Defense, 20,000 Frags Under the Sea, Atmosphere, and Island Mayhem. And then for each of the group presentations, what we're going to do is do a quick introduction of the group members, describe the concept of the game, what's going on, what were they thinking when they were designing it. And then we'll do a lengthy demonstration. We'll bring in a couple of people from the audience to play the game as well, just to show that it's not just some pre-recorded demo. And then we'll end each demo with some Q&A from you guys, if you have any questions about how it is the students did what they did. Okay, on that note, why don't we get started?